In this video, we're going to show you how to scale analog data coming directly from a microcontroller. In this case, we're using an Arduino Uno, but you can use any sort of microcontroller that you have, including a PIC, a pickaxe, a basic X, basic stamp. Any microcontroller will do, but normally out of a microcontroller you have straight analog to digital data. And if it's a 10-bit analog to digital converter, it usually goes from 0 to 1023. And normally, those values represent a voltage scale of between 0 and 5 volts. So that's what this video is going to be about. We're going to show you how to scale a 0 to 1023-bit analog to digital data output to a 0 to 5 volt type scale. So we want to start again with our Arduino unit. We've seen in our basic connect video that we have simply a 10K pot connected to the A0 analog input, and the only other connection we have is a USB cable to our PC. So that's our hardware setup. The analog input pin as A0. We're going to set our sensor value to begin to be at 0. Then for our setup, all we do is set our serial begin to 9600 baud. And in our loop, what we do is we read our analog input pin, which is our potentiometer. We print line, meaning that the print line instruction generates a carriage return after every value that's sent. We delay 100 milliseconds, and that's it. Let's go to the MakerPlot screen, and in this case, let's see, we're going to choose the channel monitoring interface, and we'll let it load. And we see that in our control section that our Arduino is connected on COM port 9 with a baud rate of 9600 baud. Also to the right we have 10 channels of analog data that we can display, but we're really only going to display one channel, so let's turn off the other 8 channels. Come up here and turn off 9, 8, 7, and so forth. So all we're going to do now is display one channel of analog data, and then we're going to show you how to scale it, which is the important part of this video. To begin, let's go to the rocker switch, turn it on, and we'll begin to plot some data. There's our data up there at about 500, and we notice down here on our channel 0, the value is 499. We can decrease that down to 0 and increase it up to 1023, which is our maximum A to D value. So we know that we're generating the proper analog signal here for scaling between 0 and 1023 to 0 and 5 volts. Okay, so let's get to the scaling part. Come up here to the configuration pull-down menu. Click on the Colors and Scale tab, and we notice we have channel 0 checked and all the other ones are unchecked. And then here's our scale value. Our scale value right now is set to a ×1, and our bias is set to 0. So what we want to do for this particular example is we want to key in a value that is representative of 5 volts divided by 1024, and that happens to turn out to be 0.00488. And notice that we can input this sort of value into our times value here. Hit the enter key, or rather hit the set key. Alright, now we can drop our configuration menu. And as we adjust our potentiometer again, we notice that our our line is barely moving at the bottom. The reason for that is our Y scale right now is way too high. Instead of 0 to 1,000, it should be something like 0 to 5. So let's come down here and decrease our Y scale. Now that's a little too much. Let's change our Y scale to a maximum value of 5. Okay, so now our Y scale is going from 0 to 5, which represents 0 to 5 volts. As a matter of fact, let's label our Y scale analog volts. Okay, there we are. So we have our Y scale set from 0 to 5, and we have it labeled as analog volts. Now let's adjust our potentiometer, and we notice that we're going from 0 to 5 volts. And we see that on our indicator right here on the right-hand side. So that's how we can scale analog data directly with using MakerPlot. Now notice we didn't have to do any kind of scaling in our code at all. It came into MakerPlot as a 0 to 123 step value, and we have converted it now to a voltage value between 0 and 5 volts. Now we're only doing this with one channel of analog data, but we can also do it with any number of analog channel data up to 10 channels. So that's how to really affect your A to D output by scaling it directly in MakerPlot. So I hope this video gives you an idea of how to do it. Once again, we come in here to our configuration menu and simply put in the scale value that you need to affect your particular analog scaling application. And once again, not only can we scale it with a fractional value, we can also add a bias to it, which we're not going to do, but we can actually add a plus or a minus bias to the data. And that's also very important if you are plotting analog signals that go below ground as well. So I hope this video was informative for you and that you use MakerPlot scaling capabilities to scale your data as it comes in.